Good evening, members. I once again welcome you to my presentation, which is a continuation of the project that I'm working on. We know that any project that is being worked on in AI or artificial intelligence, you will use data set, and this is the data set that I'm working all along with it. Amazon review data set. Today we are going to do some data cleaning and analysis on the data. My name is Momza David. So let's continue as we look at the way we are going to observe this as we see the diagrams, the plots, using particularly Python and the notebook. So among the definition and the facts that we know that data analysis is part of the statistical practice concerned with reviewing, communicating and using data where there is a low level of knowledge about its cause. So we want to discover relationship between the entities of the data we are working on. We want to remove the irregularities and unnecessary values from the data. Those are columns, for example, the named or unnamed data. So we want to find out the various patterns which prove to be fruitful for further data processing and modeling of our data set so that we can be able to predict. First we begin with the features of the heat map, and we are saying that we are going to use the random values of the feature and the capacity coverage to the cluster group. Clustering, remembering we are grouping, we are classifying the data into groups, and this is the code that I used. We are saying that I did first import the NP, then the pandas, the data frame. We are going to use the data frame here, the Seaborn for drawing the plots, and the MATLAB for the plots of the graphs, and the plot also PLT. So here we are saying that we use the index 0 up to I'm saying 6. We declared the columns that we are using. Before that we did import the data in form of spreadsheet. We imported the data. That is usually we write a command spreadsheet equals to pd.read csv into brackets. Then we were able to put the folders in which we want to put from into strings. So that's what we did. We shall see it in our coming code. So we are seeing that we did the data frame, and we are using random picking. So for example, if we picked these features, that is 7 and 6, so we are also declaring our index and columns as calls, and we are using our title here. So we are plotting the heat map, which will show us the coverage to cluster. These are features. So we are seeing that we are using even the scene Seaborn SNS.heatmap. This is for data frame, and then we are setting the value to true. So this is our plotted heat map showing us the features here and the index here. So this is our coverage. We can see 1 point something, 0 point, even our scale here, the negatives. So the heat maps are covering the clusters that we have used, and this shows you the capacity of each feature in the index, and here in these squares, that's all about heat maps. So if you want to randomly choose the values and capacitor for coverage, we use heat maps. Then we are looking at another very variable correlation matrix. If you want to compare coefficients of the correlation between different features or attributes in the data set, we are using this. Remember, we have used already our data frame, so we just call our data frame, but here we are adding a dot correlate because it's a correlation. So we print our title. You're seeing this line here, so this is the correlation. We usually refer this to as the negative correlation. So that's the correlation plus the values here, the scale. So we have called upon our index and our columns. Those are the features, and that are the index. The index is usually by default, maybe unless if we try to classify one that we want, but it is usually the index. So in our next slide, we are seeing the plot box. We are using now random selection. I'm seeing 1, 2, 3, 4 random sample. Then we are bringing in our data frame. We are using our shape. This is shape 10 by 6. So if this is 10, although I'm seeing here, when we scroll down, we are seeing other features. So we plot the box. Here is the way we plot the box. We equate it to the data frame, and we put in our columns after declaring. So plot box are used to show description of numerical data, especially when you want to compare them between multiple groups. So our median, the quartiles, for example, we are seeing a 0.4 here, the median here in the middle. So this is the middle, it's the quartile. This side here, this is for the low and this is for the high. So our other, this is when we use the review text, one column. For this one here above, we can plot various features that we have used. In case if we want a code of one feature, we can do that. So that's over here. When we do it, we are getting this because of one feature. So then we are seeing now on the next slide, we are seeing the feature dependency plots. Here, since we want to plot every feature, we use kind equals to histogram into the string. We set our title here, the grid true fig size to then the font size. So we declare our labels. Label, this is the test score. So we want to show the count of values within the data set. If it is for the text, if it is for text view, if it is for the ratings. So under here we have the score. We have even, we usually separate them by colors, show the independency. So we have purple, we have light green, we have red, we have helpful, example helpful, a feature we have this. So we are seeing it is 4 number of times. Then we have the score starting from 0.9 to 0. something like 5. So the number of counts are 4, and the score is from 0.9 9 to 0.2. 1, so 5. So 1.5, that's the score. You are seeing now the outliers. When we deal with the outliers, we are estimating the level of noise, and in order for us to define which the noisily affected points are usually the ones that are scattered here. For example, we declare the noise level using our feature 6. Remember, I'm using a rate takes the one that you saw there before. The outlier rate you can set at any, and then the level goes to 9. So we're able to print here, and this is our graph. So this out here, it is affected by noise, so it's scattered fully. So if example, if I decide to draw here, let me first draw here, and I say, so if it is a graph, then the other one is out, because if I say like something like this, it's far ahead. So you're saying this one is also out, this one is also out, in case you're drawing. So noise is affected, that's the noise. So if I'm kind of, I want if I had 1000 features, then these points would increase, and even the level of noise would increase. So it's according to the number of features that you have. Illustration of the patterns of interest. So the patterns of interest, we are seeing that we are calling again features. As long as we call the data frame, remember we imported it and we called it and we printed it. So we are using this code here, pair plot. So the pair plot, we are seeing the text review, the ratings. This is usually kind of a big diagram and displayed that if you want to take a peek, you take part by part. So these are the histograms. This DF, you know, that is the data frame. So these are the points of interest. These ones here that you are seeing, when you are seeing it's in the line, and usually even it's the correlation. So the way even the correlation is. So the patterns of illustrations of interest with the features, that's it. A section of time and space. This is expressed in observation of period data. It has both negative and low. Low is negative and high is positive. So this is the code. We are seeing that we are using graph objects as the library, PD, pad, num. So observations, you can put any, and we see. So the number of observations will increase these values here that we have set value 2, and we are seeing the date, the month. We are in Jan, we are using Jan. So as we test our model, this is what will happen. Go on. So the way the data set will behave, or the text will behave, is the way to behave in terms of space and time, by setting that. So if you have more observations, then they have to be many. Example, here you can be having something like this. So there are many, in case we have many observations, up to. So value 1 is this, and value 2 is that. So now we are going now to the next thing, that for us to get the previous features or plots, we had to do this. We had to import this, the data, using PDA. We had also to remove the duplicates. So if you want to clean the data, how the features were got, So we had to import the spreadsheet. We say that spreadsheet equals to pd.read. We read it and we put in the dataset that we have downloaded. Here I've picked it from the local machine, from my machine. There's also a case where you can just pick it from the cargo as the website. Then here spreadsheet.head we print. So in this you're seeing we have unnamed, the index, the ratings and all those. But for the ratings and unnamed ratings, we are seeing that they have two values in form of shape. Example 30, 20. So that will be used for some future also. When we come to plotting, we are seeing named. So we want to remove the duplicates. Here we are seeing this. The other diagram we have removed the unwanted columns, because whenever you try this data set, many unnamed are there. So those become duplicates. But sometimes the index can be duplicated. So you can remove it using the drop. So that's shows that we have made some progress. And then we come to splitting. Remember, we have to split the data into train and validation test also. So for example, take a case where you want 150 characters rather than that people print or put. So we set them into 3: 100, 100, 100. Those are 3,000. So we set. So we pick for this we have to import. We are using a model, a learning model called sklearn model selection. So we import train, test and split. So if you want to split, so this one does it automatically, and we are declaring the y and x variables. We know that the x, this is x, then y. 3, 4. So when we use this, we declare our labels. We declare the x and y, and we are following a valid, test and then train. So if we want to print out, we print out our models or our tests, and we group them in folders. So sometimes when you group them in folders, for those who have seen other data sets, you already find there models that have been that has grouped them into that. But here we are doing it here when we print out, we are seeing that this is for train, this is for validation, and this is for testing. So we are seeing here testing they are giving us 3, validation they are giving 1, and testing they are giving 1. I see. So training is much, validation reduces, and testing. So those are the data that we have been able to divide into test, train and validation. Then if you want to fit one initial model, remember we're using a sklearn model. So we are seeing that we are going to do a linear regression dot fit. We are going to fit our model using the linear regression. So we are seeing that if we get our model dot intercept, we are getting 3 points, and if we get our model coefficients, we are getting an array of 5 points. So there might be more of the arrays, and we are getting our model, that's the x and y train, and we are getting 0.9%. We are also getting our model the test and the train test. So test is usually 0.93, this one is also 0.98. so that's the fee. If we fit our S learning model that it learns, there are many other models that can be used. For example, those using a transformer, the GPT-2, that one is more accurate, and we are seeing here also it's more accurate. If we are able to get these values, then it becomes accurate also, our learning model. So tune hyperparameters. So here we are considering the best candidate. Usually the best candidate has the least value. So we are saying we are using the helpful value. So for hypertune we get some feature that will summarize our data. So we are using the helpful. So for it has, for example, it had 30 to let me say 12. So if you want to plot the hyperparameters, you can use this. This one will help us to summarize our data. And what's the importance of the helpful feature? So for us to be able to inform the clients that this data it has been helpful, or it is of use in case we want to predict the effectiveness of our model performance. So here we can see that we are using iterations. At first iteration, you can use a smaller number of resources. At second, we have a half, but the candidates are evaluated. Then the third iteration, we have also some resources used. This setting is best at where only we have 2 candidates left. So the best candidate is the candidate that has the best score at the last iterations. Here we're having two of them. Then we are seeing on the next page we can, how do we evaluate our valid set? So we get the validation set, you do the iterations. We are using EP or CH default values. We declare the function train, we declare also a function called evaluate, and we are seeing that after setting our iterations using our 6 features, we are seeing, and also setting our iterations, we are seeing that validation accuracy and training accuracy, we are seeing that at last we are seeing at the 5th iteration we are seeing 0.45, 0.49, and the loss we are seeing 0.7 for each, and we are seeing 0.5. So that's validation accuracy on validation. So best performance is at 0.486 and 0.49 at iteration 5th. So for training and validation, so here we have to declare functions and we set our features, usually they are called configurations, and then it iterates and it gives us the results. There are many other forms of using that. So lastly, we are seeing the references that we have used. We have Lunderberg, SMETAL, explainable AI for trees. So from local explanation to global understanding. Thank you for watching, and please don't forget to subscribe as I continue this project. So that's part of the data set, and that's the way I was able to split and explore and clean. Thank you. Nice time.